Hey everyone, welcome to this Astro image processing tutorial video. Um, Upon request of many of my friends and a lot of other people I know, I will be sharing my workflow through this video on YouTube. Um, this is mainly for deep sky astrophotography, so hope it helps you all and hope you all learn something new. So first, I will be starting with the softwares that are required for um, this, at least for what I do. A lot of people use a software called PixInsight, but that's a paid software, and I will try my best to show you what can be done with free softwares. Although I will be using Photoshop in this tutorial, which is a paid software, but another alternative is GIMP, and it works just fine. I have used it myself, and you can as well. So let's start with stacking. Um, I generally use Sequator for stacking since it's quite easy to use and it's basically a click and stack sort of software. You can use DSS as well, although for a beginner, or at least for me, I found it quite challenging to understand what's going on in the software. So Sequator, that's what I'll be using in this video. Um, that's a free to use software, and so is DSS, as well as SiriL, which I will use for pre-image processing, um, such as background extraction, green noise removal, color calibration, and histogram transformations. After that, I will be using Photoshop for my main image processing, as well as a Starnet++. This is the main game changer out of all these softwares. It's free to use software, and you'll know why. There's an optional software that I included as well. That's called Topaz Labs Denoise AI. It's a paid software, but it helps quite a lot in denoising, as it says for itself. But we will be using Photoshop to denoise. So yeah, let's begin. So first, what you want to do is go to your lights folder where you have stored your images, as well as your calibration frames. I won't be using calibration frames in this video, but you can use them as well, as I'll show. First, we open up Sequator. So this is how Sequator looks like. We have star images, base image, noise images, vignetting, and output. So star images where you want to put your light frames. I go to the folder where it is stored. Row of Yuchi, that's what I will be, a row of Yuchi, however you want to pronounce it. I will be choosing all my light frames. There are 13 of them right here. And I select them and click open. Base image is basically the image on which you want the other images to be stacked. You can manually choose which image you want, but Sequator does that once you choose your star images, so you need not. Noise images is for selecting your darks or dark files, dark frames. Of course, I won't be using calibration frames for this video, but you can put your bias frames there as well. I have tried bias and it works just fine, but that's mostly for removing using darks. Vignetting is for using vignetting images is for using your flat frames. So flat frames are for creating a flat field or removing all the dust spots from your images. I'm assuming that all of you know what noise images, vignetting, and calibration frames are. Output is basically a final stack. So I will just put this as test stack. All right, so first of all, let's see what's up with this section over here, composition. This basically allows us to choose between stacking your images and creating star trails. Since we'll be stacking a deep sky object today, we only want to stack. Now, under computing options, there are two options. That's accumulation and select best pixels. This is sigma average, sigma clipping average. I think that's how you call it. Basically, what it does is it combines all the exposures and finds the average values of each pixel and displays that in the final image. Select best pixels is only good if you have lots and lots of data, like hundreds of images. In that way, you can choose for better quality by maybe making it strict. And yeah, freeze ground is a feature that is used for landscape images. So you can freeze your ground, and using the sky region option, you can, I guess, paint over the region which you don't want to stack. Again, that's for landscape images. We are only stacking deep sky today, so we will be going with accumulation since I have only 13 frames. Align only aligns the images. It doesn't really stack, so that's good for maybe creating time lapses or something. And yeah, now on to sky region. Sky region is for landscape images, so we won't be using that, or at least when there's a foreground which you don't want to be stacked. Auto brightness is a feature that I personally keep on, but a lot of people prefer to keep it off since we will be post processing this image anyways, but it basically corrects the final image's exposure. So yeah, it just adjusts the brightness as it says right here. High dynamic range is, ironically, one would think that you want a high dynamic range and want to press this option, but I haven't found this option very useful. In fact, in some cases, it has made my post processing workflow almost fail because in some cases it just doesn't work. Now, so I would prefer to keep that on, but anyways, you can test these settings with your preference and use them. Remove dynamic noises. I always keep this on. It basically removes some of the hot pixels and all. Without, if you don't use dark frames, like how I am not using any dark frames right here. Yeah, it removes all the hot pixels and reduce distortion effects. What this does is it basically removes any sort of astigmatism or coma. Of course, it won't remove it fully, but it tries to correct it to the best of its ability. I usually keep it on. Complex is where it's at. Tele, I haven't seen it work very well. Tele is more like, as it says, suitable for telescope or simple distortion due to lens. But complex is where it's at, and I think this works the best. Again, you can try out. That's the best part about Sequator. It stacks so quickly. I'll show you soon. It won't even take a minute or two. And reduce light pollution is it's a useful feature, but I would only suggest it to use it when you are shooting from maybe a bottle class 7, 8, 9 or something similar along those lines. But then I would recommend using the uneven and maybe setting the strength to 75%. I have seen this combination work the best. But since I shot all these images at bottle class 4, 5-ish, so I won't be using that. Enhanced starlight, you can put that on or off. It doesn't really make a big difference. It does make the stars slightly more brighter, but you can turn that off. Now, merge 4 pixels. This is the main deal. Is it merges the 4 adjacent pixels to increase the sensitivity, as it's saying right here. The result. So the file size will be 1/4 the size of the original stack, but as I'll show you, the difference it makes to the images is actually insane. So I would highly recommend that you put merge 4 pixels on, unless the resolution of your image is really bad. Maybe you're using an old camera or something, and it's maybe only like 5 or 6 megapixels. Then I guess you shouldn't turn that on. But if it's more than 12, 10, 12, and if it's more than that, like 18 or 24 megapixels, then I would highly recommend that you click this. Time lapse, it's I haven't really used it yet. It's basically used to create time lapses, as it says. Color space, we want it to be sRGB. You can, I'm pretty sure that's the only one. Yeah. All right. So, and yeah, that's it. We just press start. You can look at these settings again. Auto brightness is what I usually keep. Dynamic noises, distortion effects, and merge 4 pixels. I recommend this option to be enabled. Now I click on start. All right, looks like it's done. It says completed successfully, and all we have to do is click close. Now the image might look quite dull, and especially if you uncheck the auto brightness option, it might look even more dull. So don't worry, we will handle that in post processing. So wherever you have saved your image, so I've stored it on my SD card. I will first open SiriL. It's a free software. So SiriL, I press enter, and this is where the second part of the video starts, where we are going to post process. So until now, what we did was only stacking. You can use SiriL for stacking and pre-processing as well, but it's a little complicated. So um, I would suggest that we only do pre-processing using this. So first we click on File, Open. We go to this folder wherever you have got the stacked file. All right, test stack. There you go. So once you select your image, there'll be two windows that pop up. One is the mono or single channel image, and one is the RGB image. This is what it would look like, or this is what the preview shows. Now we want to go to the SiriL control center. First of all, go to this mono image screen where it says red channel, green channel, blue channel, this place, and click on this stretching option. What it does is basically you can click on any of these and it stretches the images to however you want. This again won't directly impact the image. We want to check it on auto stretch, but you can maybe histogram or something for seeing how the image looks like. So far this is how the image looks like. We'll set it to auto stretch so that it just gives us an idea on how the image might look. This won't directly impact the image. From what we are going to do now on, that's going to impact. So first of all, I start out with color calibration. This is an optional feature, or I would say at least what we are going to do right now. So this window will pop up. What you have to do is select some part of the sky that is free of stars. You want to select a region of the sky that's decently dark and at the same time doesn't have any stars. So and you can click on use current selection, background neutralization. This is how the RGB image looks like. You can correct the white balance as well. Just click on this, use current selection and apply. That was just optional to do. If you want, you can do it like I did, but this is mainly used towards the end of what we'll be doing. So this is the main part, background extraction. Right here, you go to image processing, background extraction, and it's just 2 clicks. You have to click on generate. You need not change any of this. That's all right. You can deselect some of the pixels, especially where there's nebulae, by right clicking on them, and that works well, but I will be selecting it right there. That's all right. I'll click generate, and everything should be the same. You can make some changes, but they don't. The default ones are fine. And you click on apply, and oh man, so that made a dramatic change in the image. Now the image looks quite different. You can close that window. Yeah, so now we go for onto image processing and remove green noise. Again, you have let the settings be how they are by default, and there you go. And now for the final step, this is where you want to use, or the second final step, this is where you want to use color calibration. Like I said, you want to choose a region where there's not as many stars. And click on use current selection, background neutralization, as well as you can correct your white balance and all that, but I won't be doing that. So this looks good enough to me. There's the Milky Way right there, Rho of Uchi, Blue Horsehead Nebula, and all of that. So now the final step that I'll be doing is go to histogram transformation under image processing, and click on this wheel sort of icon that you're seeing. Click on this. It auto stretches. I'm not sure how it works, but it basically stretches the histogram, and you can click on apply. And that's it. Now all you have to do is go to the RGB image, right click on it, and save RGB image to 24 or 48-bit TIFF. You can name this file anything. So I'll be naming SiriL stack. Click save, and now you can close all of this. After this, you want to go to the folder where SiriL saves. So usually it saves in pictures. Created a separate folder on darks, but that's what I named the folder. I don't know why, but this is where it usually saves under the pictures folder. And you want to go on that, go to the picture, click on the stack, and open it with Photoshop. All right, now that it has opened, with center onto that, and I would first crop the image. You can crop it later on as well, but I prefer to crop right now as of right now as well. There you go, so that the stacking artifacts are removed. And yeah, I guess that's it. Press enter. That's it. So I guess that looks good for now, but this is not how the final image will look. There's M4 cluster right there, Antares. There's another NGC6144. I think that's what its designation is. I'm not sure. Blue Horset Nebula, and basically the whole row of Uchi region. Now, you can hit Control S for save. So either now you can go to image adjustments and curves. You can start playing with the curves a little bit, however you like it. I personally just usually I go to auto tone and see how it does. So it does not look very good. So I'll click on auto color. That makes the image slightly better. Auto contrast. It's almost like cheating. A lot of people would say, but yeah, it does a better job than I can ever do. You can change your level sliders by hitting Control L or going to image adjustments, levels. So yeah, you can basically post process however you want. I will boost the reds a little bit right now, so that the next step of this tutorial is a little easier. Okay, I think that looks decent. All right. Let me see a little more. I am blowing out Antares and M4. We can mask that later using the select and mask tool. I think this looks good for now. What we can do is now hit save, and I think I'll crop a little more because I didn't use vignetting files, so it is looking a little bad, but all right, that's all right, I think, for now. Yeah, let's click save and close Photoshop. So on to the next part of this video, we will be using Starnet++. This is the main game changer. Oh, no, there you go. All right, so this is the main game changing software of this whole tutorial. I don't know, I might be exaggerating a little bit, but it definitely does a great job. So I will include a link in the description to the Starnet++ download site. You can go to let me change. There you go. All right, so basically this is not how the folder will look like, but you want to bring your picture. So the picture was saved here, the one which we just edited through SiriL and Photoshop, and bring it to the Starnet Win folder. That's how it'll be named by default. You can change that later, of course. Um, so what you want to do is, all right. So what you want to do is select on the file, rename it to, as I say, RGB underscore test 5. Rename it to this file. Now, what you can do is actually drag this file to where's this, run RGB Starnet, but for some reason, and open with it. But for some reason, this option hasn't been working for me. I'm not sure why. So I just rename the file to RGB underscore test 5. This is how it should be by default. This is how you should name it, .tiff. And just click on this .batch file, run RGB Starnet, and click on it. That's it. So it will open up this this folder, not folder. It'll open up this sort of environment like command prompt, and yeah. So what this basically does is it creates a starless image of your original image. So that way you can only manipulate the nebulosity in your image without overexposing or destroying the stars. So yeah, right now it's 8% finished, 9%. All right, so it's almost done. I wanted to tell you guys that if it says something like your CPU supports instructions that this TensorFlow binary was not compiled to use, that's fine. That's just an error. That's it's fine. It's not really a big it's not really a big issue. Press any key to continue, and yeah. So now you will see that there are two files: RGB test underscore test file. That's the original file which we renamed, and you'll see another file, RGB underscore test 5 underscore s. This is the starless file. I'll show you how it looks. So you want to you can use them in the same folder. I'll just create another folder, stack starless image, let's say that. All right, so this is how the two files will look. The underscore s will be the starless file, so I can rename that as starless image, and this the original image, you can name that as well. So now you can click on any of them and open them with Photoshop. So this is how the starless image will look. So basically, as I said, we can use this starless image to manipulate only the dust, the nebulae around the image. So as you can see, there are no stars in the image as far as I can tell. There's only a lot of nebulosity and dust. And yeah, so we go to file, we go to scripts. Now this depends on which Photoshop version you're using. I'm assuming that you're using the newer versions. In that case, you'll have to go to file, scripts, and load files into stack. This way you can open two layers at once. So do add open files, browse, and go to the Starnet++ folder where the original image is saved. The original, there you go. And click on OK. So it should open them up. I will save the file right now. Not save as, I mean, it should. Yeah. So this is combined and no image compression, and yeah. So now, as you can see, we have two layers. So one is the starless image and one is the original. As you can see, if I you can see the difference. The Starnet++ removed all the stars from the image. That way we can manipulate only the nebulosity. So now what we have to do is basically start playing with curves, levels, and all of that. You can go to image, adjustments, curves, and under RGB channel you can I don't know. You can edit. I'm pretty sure there are a lot of tutorials online on this. I just wanted to share the main things that I find not a lot of people know about. This is especially good for extracting the IFN, or also known as the integrated flux nebulae, that lie out just outside the Milky Way galaxy, but are so faint that not a lot of exposures see them. So, and not a lot of people even know about it. So, I guess, yeah, okay. And then you can do a lot of stuff again. Levels are fine. Color balance, you can change that, or you can press auto color. That does a much better job than I can ever do. But all right, so you can start to see a lot of the of course there's a lot of noise in the image, of course, because this is only a 42-minute integration. No flats, no bias, no darks, no calibration frames. And yeah, so now what you want to do is, once you're done with your curves, adjustment, levels, um, and I don't know, you can use auto tone, but it doesn't look very good to me. So what you want to do is click on the starless image layer, make sure that it is above the original layer, and click on this option, the layer options, and instead of normal, click on lighten. There you go. All right. Without with the starless image and without the starless image. So there's quite a lot of difference, especially the Blue Horsehead Nebula. They are popping out quite a lot. Of course, I didn't edit it properly. It's just for the sake of video that I have um, done it pretty quickly. Or else I would suggest you take some time and see what looks good. I'll crop this a little more. And yeah, so once you're done with that, I think I've overexposed Antares and M4 cluster. So okay, let's just leave it at that. After this, you can change maybe the color balance for the original image. You can do auto color, but I guess you can. The best way is to go to image adjustments and color balance, or click or type Control plus B. Yeah, I guess you can change it to however you want. Um, but yeah, I'll save this now. Uh, what you want to do is click on the starless image, go to filter, and this is where the optional part comes, where you can use the Topaz Labs denoise AI. That works really well. You can use that to denoise, or you can go to camera raw filter and denoise, because as you can see, there's quite a lot of visible noise in the image. Um, the main key to success for this is to do quite a bit of noise reduction. So we will go. That's a little too much. You can adjust the slide as you want. I think that looks good. That did slide. Bit of noise reduction. Not too much to be seen. Of course, if you can somehow get your hands on Topaz Labs, that does a much better job. That way you can do a better noise reduction. And the same goes for original. Now this is where I would like to do star reduction, but because as you can see, there are quite a lot of stars in the image, and I would want the image to be to have slightly lesser stars, because it's getting quite crowded. But you can leave it as it is if you want. What I would do is go to select color range, and using the eyedropper, maybe click on some 2-3 stars, the brightest, the and the darkest stars, or not the darkest stars, but the lesser brighter stars, and go to highlights. We want the range to be as high as we can, and choose the fuzziness somewhere in between. You can mask this area out. I won't do that, but you can mask this area out by either going to select and mask, or erasing it from this selection. Now that the stars are selected, I would suggest you go to select, modify, um, go to expand and maybe expand by 2 pixels. After that, go to select again, modify and feather by 1 pixel. There you go. Now you would want to go to filter, other, minimum. Set the radius of the stars according to how you want them to look like. So this is quite an aggressive uh, removal of stars. So we don't want that much. We want just we want it to be just around 0.3. Okay, 0.4 looks good, I think, for now. Let's see how it looks. You can always go back. Okay, that's quite a lot. So as you can see, a lot of the stars are gone. What we can do now is I would save that, and this is where and make sure that you have selected the original image when you did the whole the previous section. So now you can go to Topaz Labs Denoise AI, or you can use the inbuilt, one second, inbuilt noise reduction as I had shown you earlier. It's a little better with Denoise AI. I highly recommend if you guys can somehow get it. AI clear, click on this one and click on high sharpness and remove noise. This I feel is the best you can get. It's quite a decent bit of noise, but at the same time it stars. So this is how the original looked, and after the original. So this looks much better. So click on apply, and you can choose on medium if your image looks really bad. And yeah, there you go. So this is how the image looks like. Um, if we zoom in, this is how the stars look like before, and this is after. So decent bit of sharpness as well as a little bit of noise removal as well. So yeah, and I guess that does it for the most of the video. I guess we can do a few other things. Of course, the main part is to play around with the starless image, and I guess, I don't know, you can play around with it however you want. Of course, I would suggest it takes a lot of time. I took a lot of time in my attempt. This is how my attempt looked like. Let me see. There you go. Um, Again, this was just my first attempt. I took quite some time. Okay, no, not this one. This was a bad one. This was all right. This one, I think. Yeah. So this is how it looked. Of course, the color balance is slightly off. A little bit of more bluesy vibe going on here. But I mean, there's a lot you can do, of course. So yeah, I guess that does about it. Just I would suggest that you take quite some time, take more time, and that's the part about processing. It may even take up to 4 5 hours or even more. The best, play around with the curves and levels. Curves should do fine, uh, and yeah, you can play around with the curves selectively as well, by only stretching the red channel. That way you get a little more of the reds and all. And I guess, yeah, that does about it. So thanks for watching this video, guys. I hope you liked it. I hope you have learned something new. Um, I'm not very good at making YouTube videos. I have made many in the past, but I hope this reaches out a wider audience and people get to know. These will be the softwares that I will link in the description. This is a paid software and this is a paid software. Everything else is free. So this video should work with GIMP as well, as I said, because GIMP allows histogram transformation, basically using curves and levels. And yeah, that's it. Thanks for watching. and I'll see you guys next time. Peace.